with EE Times. Welcome to this latest edition of Silicon Grapevine. My guest today is Bill Chappell, who is a CTO of a division at Microsoft. Bill, hello.
How you doing, Nathan?
I'm fine, thank you. So, Bill, tell us your role right now. I think you've done quite interesting things in your career, but what's your current role?
Right now, I'm the CTO of the Microsoft Discovery and Quantum group, which is really focused on new capabilities at Microsoft. So between research and product, right, we're building things like a quantum computer that will be, the next generation of our cloud as a new capability and new product. We also have the Microsoft Discovery product, which is the intersection of AI and discovery, things like science, things like discovering new design patterns. So how do we curate agents that specifically know how to discover new information and then work with the human on what that information means?
We covered this elsewhere in EE Times, so I'll get our sort of viewers to watch that. But in terms of like your background, now
Hmm.
you did study electronics, so I guess that
Yeah,
most of our guests either study electronics or communications or
right.
electrical.
Yep.
Is that something you've always been part of?
It is my background. So I was a professor at Purdue University in the electrical engineering department. So hardware is really my passion and focus, and really where my PhD was focused, really electromagnetics. So at Purdue, I ran the field and optics department for a bit, but really focused on the application of electromagnetics for things like wireless systems, next generation radar, and built a team, of experts in RF and microwave systems. So that was sort of the first part of my journey, and did that for nominally a decade. And then the government tapped me on the shoulder and said, "Would you like to run things at the national level?" And so I joined DARPA to run initially RF programs, and then became the office director, and that became sort of all things hardware, and really specialized in all things hardware up through firmware and some software programs. And that led to eventually the establishment of the ERRI, which is the Electronics Resurgence Initiative, which was about $1.5 billion for the research community to sort of focus on hardware and I'd say hard technologies and materials based and semiconductor technologies all the way through circuit design. And so our realization was that had been underfunded for some period of time, and so set out to really work with the community to figure out what that next generation of opportunities would look like. And then, as that's rotational, I did that for 8 years, and then was able to join Microsoft for the last 6 years and been in the CTO role.
Okay. Going back a little bit further from Purdue, as a child, were you interested in electronics, or I mean, how was this
Yeah,
interest initiated? Why did you
that's great.
choose electronics?
It probably, I started junior and senior year in high school, where we built an electric car. There was an electric car competition where really the shop teacher just built this team of scrappy young kids, and that just built literally a car from scratch. Got metal and bent it to form the frame, and just co-opted forks from a ATV, and wheels from a different from a bicycle, and we built a car, and it actually went, I forget how long, but it went quite a while on a single battery. And it was a great challenge problem because it everybody had this exact same power source. Everybody got one battery, and how far and long could you go? And you happen to win, and that's always exciting, and really got me thinking of engineering as a focus.
Yeah, interesting. I mean, kind of. I remember when in high school, I
Yeah.
built a lie detector because I knew about
Yeah.
moisture detectors, and
Right.
in my science project here, just basically sort of using that, and it was really fun
Yeah.
because a lot of people all
Yeah.
love that.
Yeah, 1993, 94. Obviously electric cars had existed for a while, but the fact that a couple of high school students could put that together was something I was really, really proud of. And the fact that, the state of Michigan ran that competition, I think was pretty prescient. And, so.
And did your parents like support you when you said, "Okay, well, I'm going to do electronics," or were they like, "Oh, what's that?"
Yeah, I went to the University of Michigan, and the engineering school was, very good. And then I, swum around, maybe a mechanical engineer. I was actually a political scientist for like a semester or two, before kind of realizing that electronics, and really the a really good early electromagnetics course was what did it for me, and wireless circuits and that intersection of antennas and waves, and this idea that these invisible waves are powering everything that we do now is like really exciting, and so got me to focus. And I did a PhD, straight from undergrad, so I just stayed directly, and got done in around eight years from entering undergrad, and so I got really excited and into the lab, and where it got beyond just theoretical, I was able to take sort of that electric car experience of like, let's go build something and bring it into the lab and do some interesting things.
So that was like your Purdue, and yeah, for some time. What are the things I think that you sort of enjoyed and liked as a
hmm
professor or doing a PhD? Yeah, with anything that you think was really, yeah, I did that.
Yeah, well, I mean, there's two things. Really, the people is the number one product, of a professor, right? So I'm very, very proud of the students that we, created and produced. And so, we built the first all digital, digital every element radar. And again, kind of just probably outperformed what I think people thought was possible, right? That you could take analog to digital converters and FPGAs and build an all digital network that could do multi-beam tracking. And the fact that you could do that in a university setting, and probably was that 2003, 2004, right? That was very early recognition of just where, how far up the stack that the digitization was going to be able to push. I carried that forward into the government and created a program called ACT, where we really, did that with some blazing speeds, but were able to nucleate that at the university level. So that I think our tunable filters were really state of the art at the time. We were able to tune from 1 to 6 gigahertz with Qs on the order of 1,000. So if you're in the RF space, like it was very, very hard to get anything that would tune that had really high quality performance. And so we weren't sacrificing adaptability for performance. And so there's a series of students and papers that kind of push that state of the art at the time.
Now, curiosity. I mean, how do you become a program manager at DARPA or as you started? I mean, what was that transition? How, did somebody call you, or did you apply for a job, or?
They called me. I was a performer for them, and so they kind of just basically said, "Hey, we like what you're doing. The next stage would be for you to kind of do this, national scale, do national leadership, and say, take these ideas to whatever you think the next level is." And so, yeah, being a faculty member was hard to hard to get to that position. It was a hard decision to make that call to do national service. Probably the best decision I've ever made. I
Mm.
think everybody should look at national service as part of their career. But it was incredibly exciting to then have the world, or at least the nation's best people, wanting to work on your ideas. And so we were able to create an adaptable RF technologies. Some of the things I'd done in my own lab, sort of at smaller scale. Now we're creating something called the RF FPGA, right, which is a fully adaptable system that could be programmed to become the RF system that you want, but after manufacturing, not before manufacturing. So a real shift in adaptability and kind of the focus of how you think of RF systems, which are historically really quite bespoke, developed. The all digital array work that we did, I think, was groundbreaking as well. We had 100 gigahertz sample per second digitizers that were built, and the ability to make decisions on what was important in the spectrum at any one time. We were able to do some really interesting work there as well. So it was it's a shift because you're working on individuals' PhDs, and now you're thinking, what can an entire lab do, or what can an entire company do, and how do you empower them to do their best work? But ultimately, it's the same concept. You are there for the people that are working with you, and they're not working for you. And so there was a pretty natural shift of focus on students to the research community.
Are you, in your role, with DARPA, were you kind of facilitating and enabling things to happen, and sort
Yeah.
of you have to have that understanding, I guess.
Yeah, it's important. DARPA exists to serve the communities that are doing the research, right? So, and the end users that need the new technology, right? So they're a bridge between the outcomes that are, required by the Defense Department, but the research community that exists, across the country. And so DARPA, done right, is extremely humble about what its role is, creating new ideas, but then allowing folks to realize those and actually do the hard work of actual capitalizing on what that is, and not being too directive in exactly how to do it, right? And so, at its core, it's a funding agency, but it's a funding agency with an urgency and an outcome that they're trying to drive, as opposed to just funding for the sake of funding.
Talking of outcomes, and this is not an interview for for your
Yeah,
appraisal or anything, but
yeah,
what do you feel were your sort of greatest achievements? And I know, there are certain things that happened as a result of your work,
yeah,
but
yeah.
what do you feel were key outcomes in your tenure, and what you feel proud about?
Well, there's a lot of great programs. I think the biggest thing that I'm proud of is the ERI umbrella of programs, right? So, we basically put on the map that the semiconductor community and the design community was basically underserved by new ideas. And so putting $1.5 billion over a 4-year period was a non-trivial sort of injection into really the electrical engineering community, like electrical engineering plus computer science and some of the other, so it wasn't just for electrical engineers, but it was, including electrical engineers, which was an area which had kind of not been served the way it had been, historically. And with that, we did some really early look at automation in the design process. We had a series of programs, Craft, Ideas, Posh. Names don't really matter as much, but it was, how do you do more with less uh, people, and not to replace the people, is to be able to do more designs, right? Because especially in the DoD, but any small entity was suffering from the same thing. Like there was a pretty Herculean effort required to get a new design, fully finished and validated, and so not enough stuff was starting, right? And so only the very largest entities were able to do some of the new designs, and so really, shortening that and automating a lot of those functions was the goal. I think we put a lot of really good ideas on the table. I think you're starting to see them, come to fruition.
And I mean, that must have been a tough time because it was sort of verging on that dot-com boom era when the focus was all off onto
Yeah.
other areas. And then you think, did you have a hard
Yeah.
time trying to convince people that this needs to be done?
Yeah, I mean, yes and no. It's all about telling the full story that, AI was coming. So we had AI Next, which was I2O, or the Information Offices program, which we were able to point to where existing AI today was going to fall short of the goals. And this is 2016, 2017 timeframe, and there's a really great DARPA perspective on AI that came out, which basically said, like, here's what we can do, and it's exciting, but it ultimately is limited, and you can't have contextual information added to the AI of that era. We were able to then point to the hardware that you can do that at the software level. You also have to look at a revolution in hardware that's going to support that,
Hmm.
and I think we were right that it is a mix of hardware with software that allows you to make the big leaps. And so I think we were able to sell the full story, or tell the full story. Whereas people were looking at just the outcomes and saying, "Oh, I want more AI." It's like, yeah, but you need to look at why the AI can do what it does, and what the limitations are based on the foundation and the underpinning infrastructure. So I think when we told that full story, it was relatively easy,
Easier,
and
easier.
yeah, easier. Yeah, yeah. And I think I think the country has woken up to the importance of the semiconductor space. In part, I wouldn't say just us, but like we were able to show, like, hey, if I want to design an advanced capability, I don't have a location to do it, right? So I have something at 45 nanometers or 90 nanometers, my option. Like, here's the performance I can get, and here's what I would do if I was out in the open market. And so that dichotomy was uncomfortable. And so that's the type of thing you can point to, say, hey, we need to sort of shift the discussion, but do that in something that embraces sort of the open, ness of the community, because we had done really well as a community and as a country, right? Embracing that openness. So how do you get that balance right? And researching and getting new ideas into the mix was part of that solution.
What do you feel you learnt most from that period at DARPA?
I think, when we first started, it was, hey, we're working with, the research community. These big corporations won't want to collaborate with us. They have all the money in the world. Why would they want to do a government program? It was actually the exact opposite. They wanted to engage in the community. Synopsys, Cadence, Mentor/Siemens, right, all joined in on the projects. Intel, you name it. Like, all the big companies came and did work sitting side by side with the research community. Ultimately, they always have, right? Even if you're just funding the research community, there's
Yeah,
always relationships that are happening in the background. And
yeah,
so this was sort of more of a, upfront, hey, let's pair these collaborators together so that we can get, a more directed outcome than, that sort of multi-hop thing that was naturally happening. And so I learned a lot about sort of the cynicism of like, no, we can't do this, can't do that. It's like, no, you can. And the government is a convening force to have some of those conversations was powerful, and something I learned that I shouldn't be as cynical sometimes. And that, good people want to do good work, and if you have a vision, like, people want to follow that vision.
I mean, I've been very narrow in my industry, which has been semiconductors, but I do
Yeah,
see people want to do good things.
yeah,
I think yeah,
yeah.
it is that.
And I think, the things we set out to do in ERI, like, they were a bit early, and I'd say, like, automating design processes, like, they got better, but, like, right now, I think is actually the right time because of some of the AI advances that happened
Mm,
in parallel. But you're going to have a revolution in new materials, the speed of which you can actually validate a new design. I'm actually very optimistic, and that will take some of the ideas we had under ERI and just make them much more applicable, but very, very healthy for the electrical engineering community, right? Like, you can start at a base material development and get it into an ecosystem that felt very far away, right? It's like, why do I want to do a new material development? I've got
yeah.
10 years of validation, and I hope the market's right. And the other end, like, all of that, I think, is going to compress, and that, allows for a much healthier, part of that being the invention cycle. Because I think people realize when invent at that level, you end up with a depth and frankly, a technology moat that is, something that uh, corporations really, care about, right? And so it was all about software. When I started, it was, software is eating the world. Now we have a very different dynamics where people are realizing that the hardware architecture at the bare minimum, but even some of the materials can be part of the differentiation that gives you a much wider gap than just, executing software faster.
Indeed, yeah, yeah, I think we're seeing that. So the tenure finished at DARPA, and then so did you sit around thinking, "What do I do next?" Or did Microsoft pretty much say, "Come on board"?
Yeah, it's interesting. Like, DARPA is a rotational, program or employment opportunity. You get your expiration date on your badge the moment you get there. Right? It's the only place where I know that you literally have an expiration date, and it follows you everywhere you go. But which is super healthy, right? Which means you're going to leave, and you don't leave on bad terms. You leave on good terms. The only place where I think at least half of the going away parties are cheers of joy and happiness and celebration, as opposed to someone being walked out the door. Other ways people leave. So it's a good thing that you want to leave. It's part of the uh, concepts and the program, and it's baked into the innovation cycle, is that you can't have people in permanent positions. So you start looking, and I was very lucky that I was able to find a position with a company that was still able to scratch my itch of doing mission impact, right, and scale impact, right. And so the big tech companies at this moment are having a moment in terms of how they're changing
Yeah.
everybody's lives. And so when you're at DARPA, if we like to say, if you weren't inventing the internet, you got to be plus, right. It was like that level of expectations of what you're doing. And so at this moment, some of the big tech companies, including Microsoft, were doing things that felt at that scale.
So you were in the right place at the right time to get this kind of role, I guess.
Yeah, I think, and been very fortunate to, go from academia into government and industry, and kind of see it from the various different piece parts, and then yeah,
Those are 3 different areas. When you talk about, um, innovation ecosystems, you need, the academia, you need
yeah,
the talent, you need customers, and
yeah,
you need, um, the companies to be
Yep.
do it. The three
Yep.
things. You've been on all the different sides. What's your observations now being with Microsoft for 6 years almost? I think.
Well, I think it's, yeah, no, it's a great question. You need all pieces, and I think actually some people are getting that wrong. They look at the outcomes that maybe a company can deliver, and it's like, "Oh, what if you just did the company piece?" And it's like, well, no, it's part of this evolution. We were talking earlier about, it's big tech motions, right? And what it takes to do something like sort of radically different. I'll tell a little bit of a story outside of my domain, actually, but the Cyber Grand Challenge in 2014 was this really interesting question of could you autonomously find a vulnerability and exploit it in the capture the flag world? The answer was no, but you build that community and it goes from an idea to something that's interesting. It evolves. Now you ask it in 2025, and we just had, I think, a very momentous capability demonstrated at DEF CON, both automatically finding vulnerabilities and patching them, and then also a computer beating hackers head to head in some of the hacking competitions. That doesn't happen overnight. That takes, an entire ecosystem and a decade worth of nucleating that, and people coming in and out of government, working in academia, working in government, working in industry, right, and all collaborating to have that sort of decade level shift to the point now. I think we all believe, right, that we just crossed a really big milestone, which is you can find vulnerabilities um, and patch them autonomously, and that's going to be this next wave of utilization of the technology, which kind of was an idea in 2014, is now going to be part of our product base. That's you have to, and now I've seen it from all of these different pieces, and each side likes to think that they're doing the most important piece. No one's doing the most important piece, right? It
It
really
all
is
plugs in
the
together.
all coming together, and the value to open research is, it's the hardest to see sometimes, right? But it's essential, right? It's the base in which all these things are built on. If this was done just in private labs or in corporate lab where we weren't sharing, yes, we would have a new capability, but the world wouldn't know, and it would just be for us. The fact that DARPA just and ARPA H together ran the AICC program, that's a benefit to society because this moment that just happened is now public, and they can stare at it and say, okay, what do we do when we have this big momentous occasion, and that's not happening just in a private lab that then kind of sort of surprise people when it comes out. And so, yeah, I'm reflecting a lot on what is that arc, and obviously everybody wants to shrink it, and they should, and we should push for faster results, but you can't change the essence of how that development happens.
Interesting. In terms of like your journey along the way, would you say there are any people who influenced you, or like
Mm.
either people you've read about, or more mentors, or people you've worked with?
That's, yes, almost too many to count, but I'll try to pick a couple. Arthi Pravakar was the director of DARPA and kind of took a chance on me being the office director, and I was relatively earlier in my career, and she, took a bet that I could do, leadership not at just the program management level, but at the office level. I learned so much from her, and she went from VC director of NIST to the VC community to be the director of DARPA, and really kind of showed me the value of kind of government service, being able to work in industry, sort of that, the ideal career path of kind of doing right for society, but also, translating the ideas into practice. And I learned a ton about Silicon Valley, a lot of misconceptions I had about what they would do, what they wouldn't do. She took me on a tour to visit, her ex shop that she was a part of, and some of the others, and like really understanding. Okay, we can't rely on VCs to do certain types of things. They're awesome at what they do, and that and you should rely on them and not get in the way of what they do really well. But don't expect them to do other things, right? And that time, deep tech was something that they were
Hmm.
shying away from. And so that's why one reason we were able to actually increase our budget is, okay, then the government gets to fill some of that void. And, that was a great lesson that I think she helped, craft that story of why we would have to do some things that are not going to be done by the by private industry. Linda Kay was my advisor. She awesome, at University of Michigan. And so obviously, your advisor is, central to how you think about a problem, how you,
Mm.
systematically try to solve it, but more importantly, not to just get stuck on one thing. I mean, she was bold enough to kind of do a couple of different things in her career. And I think that was very important for me to see. And going from academia to government industry, you have imposter syndrome at every step of the way, because those
Yeah.
are different things that you're trying to do. But having that sort of leadership to say, yes, it's okay, and you'll learn, and you'll be able to, provide value, was essential for me.
Yeah, I think that imposter syndrome is always hard to overcome, especially when you're going from one thing to another. I've changed my career several times, and
Yeah, yeah,
it's always
yeah,
like, am I doing it the way
yeah.
people expect me to do it?
Yeah, if you don't have it, you're a psychopath. If you're doing, something big and with great people, right? I remember when I landed at Purdue, Cipriodata was a professor that, at the office next to me, and like he may be one of the most brilliant people in the world, and I'm like, well, I'm not him. It's okay not to be him.
Yeah,
Yeah, I can do my own thing, right? And have a specialization, and built a lab that I'm very, very proud of, but from a different angle than just being the smartest person in the community or in the world. But yeah.
so, final question. I mean, I asked this to all my guests. What would be the advice you'd give to young William if he was
Yeah.
starting out on his career now? Yeah, or anybody starting out.
Yeah, I think on the positive side, I think not being afraid to kind of make sort of large scale leaps, right? Where some people would look at my career and say, like, okay, you kind of did the professor thing, you did the government thing, now you're in industry. Now I'm not just in industry, I'm not in the research group, I'm actually in the product group, right? Which is kind of a different muscle that I've had to learn, and just being comfortable with being uncomfortable, is important for not getting sort of stagnant. That's, I think, on the good side. I think making sure that you stick out at any one, you know, location to actually see something through, that not doing the job hopping. While I've changed, it's been on sort of a decade by decade change. And so I'm very proud of what we were able to get done at sort of each of those stages. Where I do regret is when I did leave, that maybe there's something that almost got done and didn't get done because I wasn't
Yeah,
there. Or that's the balance, and it's hard
yeah,
to know exactly when. There's never a right time to make a major shift. But overall, I think my advice, right, would be, being able, bold enough to make those large career moves, even though it's going to be a risk and feel uncomfortable. That's okay, and that you can make up for it with hard work in the beginning. That's definitely something that you have to reestablish yourself, but that you can, and that that these skills can be built in a relevant amount of time that you can contribute before people realize you didn't have some of the background.
Well, Bill Chappell, thank you very much.
Right? Thanks for netting.